LAYER3 network layer and LAYER4 transport layers. Layer 3 network layer and Layer 4 transport layers work together. They are responsible for moving messages from end to end for all packets. Network layer is responsible for addressing and routing of messages. It encapsulates message segments to send. It decapsulates packets and passes them to transport layer when it receives. Network layer header uses IP address which routers uses to find the best path to the destination network. IP version 4 uses 4 octets numbers. Each octet holds 8 bits. Bit is binary digit. To read it easily you may use decimal number format. 8 bits can be decimal number between 0 to 255. You will deal with this more deeply later. Currently there are 2 types of Internet Protocol, IP, addresses in active use. IP version 4, IPv4, and IP version 6, IPv6. IPv4 was initially deployed on January 1, 1983 and is still the most commonly used version. IPv4 addresses are 32-bit numbers often expressed as 4 octets in dotted decimal notation. The IPv4 number is limited. So CIDR, classless interdomain routing, and IPv6 were introduced. Deployment of the IPv6 protocol began in 1999. IPv6 addresses are 128-bit numbers and are conventionally expressed using hexadecimal strings. IPv6 provides a lot more IP address in the world. IANA, the Internet Assigned Numbers Authority, is responsible for global coordination of the Internet Protocol addressing systems including domain names. The IANA is a department of ICANN. The Internet Corporation for Assigned Names and Numbers, ICANN, is a non-profit organization that is responsible for overall related to the namespaces of the Internet. Users are assigned IP addresses by Internet Service Providers, ISPs. ISPs obtain allocations of IP addresses from a local Internet Registry, LIR, or National Internet Registry, NIR, or from their appropriate Regional Internet Registry, RIR. Layer 4 transport layer is responsible for end-to-end delivery of messages. It is also responsible to segment and to reassemble data. If anything missing, then it requests only that missing packet. Transport layer functions with Transmission Control Protocol, TCP, are kinking to the application layer using port numbers, segmenting, and session management. This image shows that how port numbers work to connect application layer. TCP breaks a large message into smaller pieces, packetization. From destination computer, TCP puts packets back together at the destination, reassembly. In the transport layer, connection-oriented session management, for HTTP, SMTP, FTP, is provided by TCP. TCP asks IP to route all packets in a message by using the same path, from source to destination. In the transport layer, connectionless routing is provided by UDP, User Datagram Protocol. Each packet is sent independently of one another, and will be routed separately, following different routes and arriving at different times. DNS, DHCP, RIP, and SNMP use connectionless routing. Protocol used for connectionless routing in TCP/IP suite that uses no ACK, no flow control. It uses only a small packet header, only 8 bytes containing only 4 fields: source port, destination port, message length, header checksum. In the transport layer, data is segmented into smaller segment, then they are numbered. In the network layer, segments becomes packets with packet header. Packet is generic term for piece of data that higher layer wants to send. Frame is packet encoded for transmission on this link. Data link layer sends frames, small fixed, or max, length pieces of data. Frame length specific to hardware. Packets keep the original content. However, frames are modified for each device to forward the signal to next node.